Norman, that you've been in this class this long and you think that I care about anything like that. I teach the kids that are here until it's time to not teach the kids that are here. Doesn't matter when the block ends, doesn't matter what kids are in front of me, doesn't matter what the block order is, doesn't matter if it's a Monday, a Tuesday, a Wednesday, a Thursday, a Friday, a Plu day, a Gerplox day, it doesn't matter. None of that matters. It's not going to make the class go any faster. It's not going to make the class go any slower. I just do my job. Don't borrow problems from the future. And a problem from the future is sitting there going, when's this class over? So everybody should be done this. Luke said wisely, Dryers, I can't get the y-intercept on the graph. It's so big. You're right, you can't. So you had to go down 2 and over 1 from it to get to 1, 9. Then you could graph it. Right? What do you see? What do you mean you don't know? Just tell me what you see. Don't try to answer a question. I asked you, what do you see? You see 2 lines that do what? Intersect at a point, which means it is a system with a solution, yes? Yeah. Now, let's make a conclusion. What do you notice about those 2 lines? Why? What is it about those 2 lines that allow them to intersect? Their slopes differ. Right? So, if it happens once in math, how often does it happen? Every time. So, if 2 lines have different slopes, then their system has how many solutions? 1. And it can only have 1 solution, can't it? Why? If there's 2 lines, why is it that there can only be 1 solution? Because the lines cross, and what is going to happen to this line, the blue line, forever? Go that way, up 2 over 1, up 2 over 1. What about that way? Down 2 over 1, down 2 over 1. What about the purple line? Same thing. What is going to happen to this gap? It's going to get bigger and bigger and bigger and bigger and bigger and bigger and bigger. Is the line ever going to turn? No, because it's a linear equation. It's not an absolute value function. It's not a parabola. It's not a hyperbola. It's not an ellipse. It's not a circle. It's not a cubic. They're lines. So they can only cross once. And the feature of the lines that allow them to cross once is different slopes. Graph these guys. Purple, 4y equals negative 2x plus 12. Y equals negative 1/2 x plus 3. 2y equals negative x minus 12. Y equals negative 1/2 x minus 6. Graph them. 1, 2, 3. Down 1, right 2. Down 1, right 2. Down 1, right 2. Forever and ever and ever. Negative 6. 1, 2, 3, 4, 5, 6. Down 1, left 2. Down 1, right 2. Down 1, right 2. Forever and ever and ever and ever. What do you notice? That you notice a couple of things. 1, you notice they're parallel, which means what? What does the word parallel mean? What's the definition of it? 2 lines that will never cross. If they will never cross, how many solutions will there be to that system? You're just saying words. Which is it?
None.
None. Absolutely right. You deserve an award.
I did. Oh, yeah. Thanks, bro.
Jalem, I feel you are wasted in northern climates away from the ocean like this. You should be on a beach in California with a basketball court and your surfboard leaning on a bench right beside the basketball court. So when you're tired and hot and sweaty from basketballing, you can go down and surf a little. Then you can come back up and say, "Hey, brah, let's go get some tacos. The taco truck's right over there."
That's gnarly, bro.
And then you can go back to balling and surfing.
That's actually pretty cool.
If you're really slick, you could move to Venice Beach, where there is basketball, skateboard bowls, surfing, and handball courts. You could cover everything, all the hip, cool California things to do.
No way, bro.
And it's right beside Muscle Beach.
Yeah, lots of women. Why did your face so dull after you said that?
Okay. Everybody understand? Yeah?
Oh yeah,
Okay. Why am I showing you this?
they're fun.
No, not really. I'm showing you this because it can save you some hassle, can't it?
Yeah.
If you just look at equations and you see that they're going to have the same slope, do you have to bother solving the system? No. You don't have to because you know there's no solution, right? Now there's one other option here. What do you notice about these guys? I'll give you a hint. Boom. Boom. And boom. What do you notice? They've all been multiplied by 2, right? What did we learn yesterday when we multiplied lines? It gets the same line, right? So if I graph this first one, 3y equals negative 2x plus 5, y equals negative 2/3 x plus 5/3. First of all, it's a little tough to graph. What do I have to do to graph that? What do I got to do to graph that? I got to change the scale. 1, 2, 3, 4, 5. Put my dot there. 1, 2, 3. There's 1, right? If I keep the same scale down here, 1, 2, 3, there's 1, then I can just go down 2, out 3, down 2, out 3, right? Now, the other one in purple, we know is going to come out to the same thing, yes? So if I were to put it on this graph, where would the purple line be?
It would be over.
It would be right there, yes?
Yeah.
How many times do those lines touch?
Every time, all the time.
Infinitely, right? Every time, all the time. So, if the lines are the same, oh, not if the lines, sorry, dummy head. If the equations are the same, then the lines are the same. And there's infinite solutions. Now, this should take about 10 seconds without solving. So no elimination, no substitution, no graphing. Tell me how many solutions these guys will have. What are your only options? 0, 1, or infinite. Go. Indeed, I can. Some of you will be so good at this, you won't even have to write down anything. You'll just be able to look at it and see. When you think you have it, stand up and dance the two-step. You'd think it's easy because there's only 2 steps, but it's not. Do you guys have to do dance and phys ed this year?
No.
You didn't? That ain't right.
We didn't do it.
That ain't right. Did you two-step? Line dancing.
And actually, we did do dance, but like.
That was always my favorite unit in high school.
I touch girls.
Exactly. Unlike you guys, I looked at this chance to be dancing with girls as not a punishment.
Nah, we didn't dance with girls this time.
Yeah, we didn't dance with
only
guys
danced with
either.
other dudes.
We didn't. We just like yeah, we were splitting groups of girls, and then we were just like making them dance. We didn't even talk to the guys.
Yeah, we didn't dance with other girls. We danced with my class. And it was fun.
That was awesome.
I'm pretty sure Kiri just gave up halfway through the class and stuff, but she's like,
By the second or third day of the dance unit in my high school in Vancouver, people would skip classes to go to the gym to square dance. Was how much fun we had with it. Oh well, I don't need more proof that we were way awesomer than you guys.
Oh wow. Way to go. We had fun though.
Good. So, how many solutions for the first one? 1. What was your hint? How did you know? Because the X and Y's are different and they are not multiples of each other. Yes? Excellent. What about 2? Infinite. Why?
because 3x multiplied by 2 is 6x.
If that 6 was over here, it'd be positive. 3 times 2.
Yeah.
5 times 2. And if that 18 were over here, it would be negative 9 times 2. So that's infinite because they're the same line. What about this one? 1. Because, why?
Because the slope for whichever Q or D, I don't know which one it is. Either way, the slopes are different.
The slopes are different there, really.
Oh no, the intercept's different, sorry.
The slopes are different there.
The letters may be reading.
What is it really, Veronica? It's either 5 over 2 and 15 over 4, or 5 over 2 and 10 over 4, or 2 over 5 and 4 over 10. Aren't they the same slope?
Uh-oh.
So if they're the same slope, and you notice the constant is different, then how many solutions does it have? 0. What made it difficult? I changed it from X and Y. That old troublesome thing that math teachers do. Change it from X and Y and all of a sudden you can't do math. Which is of course kind of like saying, I can drive a blue car, but I can't drive a green car.
Why would I drive a green car? That's exactly.
I used to have a green car.
Green not bad.
It was wicked awesome.
Like what kind of green was it? Like a dark green?
It was green apple pearl was the name of the color.
Like the only
It was a Hyundai car. It was Korean. Those Koreans can't build a car that can wrap itself around a telephone pole and live.
Wow.
I didn't wrap it around the telephone pole. I know how to drive. Good.
I can't drive with my mom because she freaks out about like everything. It's so nervous.
You should not teach your children to drive. You absolutely should not. You're too invested. You're too invested in your kid. You're too invested in your vehicle.
Invested? My dad almost made me crash down the hill.
That's what I mean. You're too invested. You got to have somebody dispassionate doing it. That's why you pay.
My mom like grabs up the steering wheel.
Okay, turn the page over. This is where you people either shine or fall flat on your faces. Everybody, like we have done in every lesson of this unit, read those 3 things to do. Step 1, Step 2 und Step 3. Now, this time there should be a couple of questions as to what those sentences mean. So I'm going to wait a moment, let you read them and decide.
How was the chocolate that brought you?
What?
How was the chocolate?
It was delicious. It was filled with flavonoids. It dealt with all the free radicals in my body and made me feel great.
Radical. Okay.
That's what dark chocolate is good for. It's filled with flavonoids, and flavonoids help deal with free radicals, which make you live longer.
Well, no, Mama was just asking because she's coming back with.
It was delicious. So I remind you all, you want to eat things that are high in antioxidants because they deal with free radicals. Sadly, most things that are high in antioxidants don't taste very good, but dark chocolate does.
Especially strawberries.
Acai berries are filled with antioxidants, but they taste like barf. Blueberries are filled with antioxidants, but you have to be careful because industrially farmed blueberries tend to have lower antioxidants than wild blueberries. Wild blueberries are hard to get your hands on. Unless you order them from Nova Scotia where there's a wild blueberry farm, which I don't really understand what that is. I guess the blueberries party a lot at night or something, because I don't really know how you can have a wild farm.
Well,
But-
because they have it in Germany too. It's a gated forest.
Yeah, I know what it is, Lena. I'm making a joke.
Whatever. It's really fun because they have like little, what do you call those? I don't know,
Huh?
little statues in there.
All right. So, now listen, please. A couple of years ago, I was teaching pre-dip 9, and I gave this exact question to some grade 9s. And they all had this weird method of solving it that I had never, ever seen before. And I asked them who taught them that, and they said like their grade 6 teacher or something. And I was like, okay. And then I gave them another systems question before I taught them how to do systems. And I said, do that question. And they couldn't do it because they had learned a way to solve these magical unknown number questions, but they couldn't apply that knowledge to any other type of question. Do you understand what I'm saying? So if you have some funky method for solving these unknown number questions, by all means, use it for unknown number questions. But if you can't apply it to any other system, how useful is it?
0% useful.
Almost useless, right? So, we are going to go through a method that will solve every single system, not just unknown number systems, okay? But we're going to do it starting with an unknown number problem because most of you probably have a method for solving this. So the first thing that I say to do, and I've highlighted in blue so I will use blue ink, is to identify what you are looking for and to write let statements to identify your variables accordingly. In grade 9, my grade 9 math teacher, Mr. Voth, he was brutal about this. If you didn't write a let statement, he wouldn't even mark your question.
Oh.
That was 1989. This is 2018.
Oh, that's big.
In 2018, I don't care if you write a let statement, but I do care that you have some variables, right? How many unknowns do we have in this question? 2, because there's 2 numbers we don't know. So I need how many variables? 2. Now, if you were in my grade 9 class with Mr. Voth, if you got in the DeLorean powered by plutonium through the flux capacitor and drove back in time and sat down in my grade 9 math class, you would be sitting with Mr. Voth, and you would say, Mr. Voth, why do we have to write let statements? And Mr. Voth would say, because I told you to.
Wow.
And you would say, yes, sir, and you would write a let statement. This is not 1989 again, this is
What
2018.
is a let statement?
This, let X be the first unknown number. That's what Mr. Voth wanted to see. I am not Mr. Voth.
Bro, I'm gonna go back in time.
Number 1 equals X. Number 2 equals Y. Okay? Do they have to be X and Y? No. As a matter of fact, in honor of our good friend Luke Pearson, I am choosing P and Q. Because it doesn't matter, does it? So, step 1 is done. Step 2, write 2 equations. Hint, hint. Every sentence produces 1 equation. Now, we practiced this 2 days ago, yes, when we learned substitution. I told you to take the equation 4y equals x minus 2 and say it in English words. Right? Right? So now we're going to reverse that. Now we have English words, so we got to turn it into math. What am I going to do with that to turn it into math?
Take away 48 from that first and get 7.
P plus Q equals 176. Right? Because the sum of 2 numbers is 176. They're unknown numbers, so I got variables, and sum is adding. Yeah, yeah? Yeah, yeah, yeah. What is the second equation? Because we have 2 unknowns, so therefore we need how many equations? 2. So what is the second equation? P minus Q equals 48. Have I done the second step now?
Yeah.
Excellent. Now, the third step, which I will do in green, because I highlighted it in green, solve the system via graphing, elimination, or substitution. Which is the one of the 3 that we are not going to use?
Graphing.
Why aren't we going to use graphing, Luke?
You don't have a set of coordinates or y.
We never have a set of coordinates.
Yeah, but you don't have a
So we make one x, we make one y. We could use graphing if we wanted to, but why are we not going to? Nope. We could get a slope. Why not? Okay, wise ass. Q minus P equals 48. Q plus P equals 176. Why aren't we graphing it? What?
You're not trying to graph it. Like you could if you wanted to, but you just want to find the number. So why would you do extra work and graph it when you don't need to?
There is the laziness argument. I agree. I agree with you completely. There is entirely the laziness argument. The answer I'm looking for, however, is graphing is not exact, which we found out when I gave you that warm-up question yesterday, yes?
Either way, if you give me that.
Because the lines crossed in the middle, right? So we don't want to use graphing because it's not very accurate.
It's not exactly anymore.
So we're going to eliminate graphing. So we're down to elimination or substitution. Which is the better option here?
Substitution.
You could use substitution,
Both are very.
but that would require you to do what? It would require you to move around one of these equations. But could you not just eliminate? Because Q and Q have the same same coefficient.
That is whack.
So, would I add or subtract here?
Add.
Add. What is P plus P, like how I used yellow? 2P. What does 2P equal? By the time you punch that into your calculator, I've already added it up. What is it? 224. So what does P equal? 112. What can I do with P once I have it? I can
Insert it.
substitute it into which equation? Either equation. For which letter? P, because P is 112. So would I write this as P plus Q equals 176? No, what would I write it as? 112 plus Q equals 176. So Q equals 64. And there are your 2 numbers. Would you check it?
Yeah.
Of course you would. 64 plus 112 is 176. We already know that because we just did that one. So I really only need to check the second one, don't I?
112
Is 112 minus 64 48? Indeed it is. So we know we are right. Is everybody Gouda? Is everybody Gouda? All right. In number 2, I want you to just do step 1. Just write the let statement for now. Or the 2018 version of it. Pop equals and chocolate equals.
Wait, is pop the Canadian word or is soda pop?
Pop is Canadian, but a few American states say pop. A few. It's very regional. People from Ohio say pop.
Well, like, if you think about it, what do you do to a soda can when you open it? You pop it. Pop the can.
My son likes to say soda to be contrary.
What about soda pop? Like, you can't forget about the outsiders.
No, you can't forget about the outsiders. That tough book.
Such a good book, bro.
It was a good book, written by a 17-year-old for an English class.
So
Yeah.
girl.
Yeah.
And he failed it.
It's a she. S.E. Hinton is a lady.
Okay, well, I never read the book.
S.E. Hinton is a lady, and she wrote that book when she was 17.
It's pretty good.
Yes, it is good. Having read some of your people's writing,
It's not.
I've read my own writing. I'm like, wow, that's pretty good.
I'm a good writer. I couldn't write a novel. Not in a million years.
Can't even write English.
Man, it's like a short one.
Novels, I don't know.
Not in a million years. I could maybe tell a story that was long enough for a novel, which is all The Outsiders is. Right? Novels are different. There's telling a story, and then there's novels like Tom Clancy that have all this technical stuff in it, so you got to research it like an essay.
Yeah, wasn't Tom Clancy like actually?
What's your let statement? What does pop equal? Okay, pop equals P and
Chocolate C.
great. Now go on to number 3 and do the same thing. Just the let statement. Remember, you need to decide on the unknowns and assign variables to them. When you feel you have done that correctly, tell me. So what are my 2 unknowns here? Somebody should be able to tell me by now. The start fee and the monthly fee. What are the variables you're going to use? Okay. You guys are so boring. Why not J and K?
Because
A and B? C and D? Why do they even have to be beside each other? H and U. F you. All right. And lastly, this one is hard. Many of you are going to screw it up. What are the unknowns? What are the variables?
The unknowns are 2,000.
2000's not unknown. It's right there. 2000.
It's a piece of 2,000.
Okay. How many pieces of 2000 are there?
A lot.
Read the question. How many, Keegan? 2. So how many variables do I need? 2. So what is a good one? Investment 1. Investment 2. And what are your variables going to be? Okay. There you go.
Okay.
Good comedy. Everybody comfy? Great. Go back to number 2 and do step 2. Write the equations. I will highlight each sentence. There is one equation. There is 2 equations. Write the equations. When you think you have it, put your hand up and tell me. Damaris, hit me. 4C plus 3PO equals 5.3 and 2.2. Is everybody happy? Great. Do that twice more. Go on to number 3. Do the same thing. I'm not going to highlight. You have to figure it out all by yourself. Yes, Jalem, you are now a little math bird and you can fly away from the math nest. Go. When you think you have it, hop on one foot. If you hop on one foot and have it right, I'll give you a gummy bear. Really? Interesting. And why is that? Is it because you're not confident in your ability to write 2 equations? Or are you not confident in your ability to hop on one foot? Go get a gummy bear. Well, not yet. Stephen, what are the equations? I'm sorry, louder? We're on number 3, dude. Okay. And? And then S plus 6M equals 435. Absolutely. Go get yourself a gummy bear. But you have to hop the whole way. I'm just kidding. Go get yourself a gummy bear. It would have been funny, though. How many of you thought for a second that I was serious? And it was going to make him hop all the way. Well, I know you did, Stephen. You went like,
I was ready to do it.
I know you were. Is he right? Of course he is. Everybody's saying right. All yous could be given gummy bears too, but too shy to hop on one foot? Shocking. I know you did, Damaris. You don't want gummy bears.
I want math.
All right, number 4. Go. Number 4 is significantly more difficult. I know, right?
Yo.
You know, I just had a good look at Keegan's shoes there. I would argue that a Roman would really have no problem with that because he could see that they are mesh and almost look like sandals. The first one of these should be very easy. What is it? Oh, yes, you do.
You don't know how much money you invest?
Yes, we do. Read the question. That's the whole point. So aren't these 2 unknown numbers? Like question 1? And what did those 2 unknown numbers equal? No. The 2 numbers are 2,000. So F plus U equals 2,000. Now what's the other equation?
X times 8% or 0.
So 0.08 F
Plus
0.1, not 1, 2, 0.1 U equals what? 190. Excellently done, ladies and gentlemen. Now go back to number 2 and solve them. Use your method of choice.
You know, talking about ridiculous teachers, I remember.
Ridiculous teachers? Why would you be talking about ridiculous teachers?
You talked about the guy that had made you do the let statement.
That wasn't ridiculous. That was what you did back then.
Well, my teacher would take marks off of your question if it was in the thousands and you didn't put the comma in between every third number.
That's idiotic because that hasn't been done in math since
Oh.
I was in
When
math.
You said, yeah, you gotta keep doing that.
No, that has not been done since at least
It
1985.
was either a large space on a page between the numbers or a comma.
my teacher was way more ridiculous. If I wouldn't put an X on the graph and then said a dot, she would not give me a point for it.
Ludicrous.
So that's
And
why I
people
didn't-
wonder why kids hate math. Okay. What method are you going to use here? Who chooses the method? You do. But you have two different methods at your disposal. One of them is better than the other one in this case. Substitution is better this time. Why?
The P is on its own.
Because P is by himself. So we know that P equals 2.2 minus 2C, correct? Let's go. 4C plus 3 times 2.2 minus 2C equals 5.3. 4C plus 6.6 minus 6C equals 5.3. Negative 2C equals negative 1.3. C equals 0.65. How much is a chocolate bar? $0.65, because C is 0.65 and chocolate is C. If chocolate is C and C is 0.65, then a chocolate bar equals 65 cents. You can tell how old this question paper is by the price.
Isn't that
But sometimes you can find chocolate bars that cheap in the store. Like if you're in the checkout line at Save-On, they always have a 3 for special on chocolate, some kind of chocolate bar.
in Germany? It's still 65 cents. Some of them.
Da!
You get like 100 gram for like 99 cents.
100 gram.
And yeah.
If you know C, what do you do then? You plug in C where? Anywhere you see C. I'm going to use this one because it's already set up to find P, right? P equals 2.2 minus 2 times 0.65, which is 2.2 minus 1.3, which is 0.90. How much is a pop? 90 cents. Also doable if you go to the dollar store. Yeah? Yeah? Yeah. You guys do number 3. Go diddly-o. Number 3 is awesome because it is set up for both elimination and substitution. Neither one is any easier than the other. So you can all choose. That is my mathematical gift to you.
Wait, it was 90 cents for a pop, right?
Yeah.
90 cents for a pop.
Okay, I was doing it over. I ignored everything around.
How many people chose elimination for number 3? How many people chose substitution? How many people aren't bothering to do it? The rest of you put your hands up. Because I only gave you 2 choices. Only like 6 people put their hands up. So that means 24 of you are not choosing either substitution or elimination. So I guess you've gotten out a graph and you're sketching it and you're going.
What?
Well, you must be because you didn't put your hand up for either substitution or elimination. There's no other way to solve this except graphing. You're on number 4, are you? So what's the answer to number 3? You deserve an award.
What category?
To quote the best line in recent movie history, The Incredibles 1, Mr. Incredible. We keep finding new ways to reward mediocrity.
Oh yeah!
Best line spoken in a movie in
when I
forever.
watched that as
And
a kid,
ironically
I
spoken in the movie aimed at children. And yet we continue to do so, as my poor wife has to come up with 22 awards for her kindergarten classroom. There are kids in that class that cannot bark. She thrice this year has had to clean up human feces. And that is the level that she has to find an award for those kids. They don't even know how to poo. But in North American education, make sure they get a reward, because that's what's going to teach them to poo.
When I was
Yes,
in
Rhea?
kindergarten, I would actually.
I'm sorry, I can't hear you. Of course. Yes, Luke? But you were saying something. You were just second in line. Okay. All right. You tell me. No, you just tell me. Agreed? Are we right? It's easy to check. Is 225 plus 30 260? 35. Okay. I misheard you. Is 225 plus 35 260? Is 225 plus 190 235? Oh, wait, I'm sorry. 6 times 3. No, 210. Is it? Indeed it is. So we are correct. Do I need to go over how to do it? I am actually going to do something here. I am going to do a subtraction, because S minus S eliminates. M minus 6 is negative 5M. 260 minus 435 is negative 175. Okay? Now, how does this help us in real life? This is what you use this type of math knowledge for. If I was going to graph this, there will be a red line here and a blue line here, yes? Right? The red line would have a different slope than the blue line, correct? Right? Everyone agrees? The red line has a slope of 1, yes? Because if I move the M over there, then it's in slope-intercept form, isn't it? And it's got a y-intercept of 260. So, I'm supposed to do my red line. 260, and it goes up 1, yeah? So it goes up in a nice line. The other one, this line right here, has a different slope, doesn't it? Its slope is 1/6, yes? So significantly less steep, but starts way up here, yeah? But only goes up like this. Because it's 1/6, yeah? Well, at some point they cross, yes? Right? That is a certain amount of months, isn't it? If I'm on this side of the certain amount of months, do I go to the blue gym or the red gym? The red gym, why? Because it's cheaper. If I'm going past that certain amount of months, then where do I go? The blue gym, because it's cheaper. What would the smartest thing to do? Join the red gym until that point, then switch over to the blue gym. Understand? Good. Last question. What frightens you about this last one? Percentages, but aren't percentages just decimals? And aren't decimals something we can get rid of by multiplying? And doesn't multiplying keep the line looking exactly the same? So what could I do to this to make it an equation we like? By 100 to get 8f plus 10u equals what? 19,000, 2 zeros. Now I have this system. And again, it is set up for which one right now? Which is the one I can use that will require less work? Actually, I shouldn't say that because it's what you like to do, right? I would use substitution here because I don't trust myself to do this multiplication properly. Because I know all of you would do this multiplication in your head. You wouldn't go to your calculator. And you may make a mistake. I know this. Because you think you should be able to do these things easily. Like this type of question. 3x plus 7 equals 28.5. You would try doing that without getting out your calculator. Or you would try doing it in your head. So, I would use substitution and I would change this guy to f equals 2,000 minus u, or u equals 2,000 minus f. The other option is, of course, to multiply this by either 8 or 10, all of which will eventually get me to the same answer, won't it? And what is that answer? Pardon me? $500 and $1,500. Can everybody do a system? Now, you will notice that all these four systems were very small numbers, yes? And very rarely did I throw a decimal or something at you. But could you do this with big numbers? Could you do it with decimals? All you would do is the algebra that you already know how to do. Yeah? Yeah. And that, ladies and gentlemen, is the end of Math 10 pre-day. I love you all. You were wonderful. Wait! I'm not really going to drop it. It's a nice mic. That's it.
I wonder what we're doing this video.
I don't know. So, listen please. Listen please. There is a page of practice on systems. And of course you have a review. The review is due when? Tomorrow, because we do have a class today. I didn't know we did. Because I don't read emails. So, bonus gummy bear, if you can name that font. No. No. Getting warmer. No. I'll give you a hint. Greatest video game from PlayStation 2 that now lives on PlayStation 4 as well. No. No. I think you misheard me say worst game ever. Okay. Okay. Nobody? None of you boys even?
The only game I have for PS2 was Shrek the Game, bro.
It was also on PS3 and it's currently been re-released on PS4 with a new version. Oh, getting warm. Getting warmer. Again, you have misheard me. Your definition of greatest and my definition of greatest are significantly different.
I remember I played.
It's God of War.
I don't know that game. It's so bad. I don't want to get the game.
All right. Let's go over your tests if you want.
I just want to hear you.